Hello everyone, welcome back to Concept Bytes. This is Nitish with your regular dose of data science concepts. In this particular video, we will look into the concepts of data cleaning and data processing and understand what do they mean and what are the constituent steps that we need to apply in order to implement them. So let's get down to our video.
So before we go into some of the steps of data cleaning and processing, just a reminder that I have already shared a video describing the process of data analysis at a higher level. If you haven't checked it out, please do so. You will find the link in the description so that you can get an idea of what is data analysis about, and then this video will be much more helpful to you. Okay. So as usual, we will define a toy dataset and a hypothetical situation for the given scenario so that our understanding becomes easier. So let us assume that you or me or like we are working for the government in the healthcare department, right? In the healthcare ministry or department, wherein we have access to the data set for the citizens of a country with their ID or the identification number in the first column and their age, height, and weight in the next three columns. So we have such a data set for a large number of people. Okay. So the first thing that you generally look for in a data set after maybe having a cursory look and just doing some basic checks is whether it has any missing and invalid values or not, right? So what do we exactly mean by missing or invalid values? So missing values means, let's say some data point is missing in the data or not. If it is missing, then we need to apply some treatment so that it does not give us any errors while we are trying to analyze it later, right? And invalid values mean some extreme values which, according to your business sense, seem impossible in the data set. Let us see what they are. Let us assume that there are two observations in the middle of the data set, like I am showing here. So let's say ID number 135 and 350. You would see that the ID number 350 has negative age, -3. But from common sense, we know that -3 is not possible, right? The age of -3 or any negative age is not possible as age is always more than 0. So there might have been some kind of mistake in storing this data. So this we treat this as invalid value and we try to impute it or remove it. Then we also see that there is a value in height called NA. Now NA generally implies not applicable. So this is a common placeholder for missing values in the data. But in some cases, it can be just blank or maybe a dot, right? So in different ways, you can find the missing values in the data depending on how it has been stored. Okay. And then you see there is another person who has weight of 560 kilograms. Now, generally, the weight of any person generally varies around for a healthy adult it would vary around 50 kgs or 40 kgs to maybe 150 to 200 kgs, right? 560 seems suspicious. So in such cases what we can do is we can go back to the source and we can check if this is possible or not. If it is, or if it is not possible, then how is it coming in the data? There might be some error in processing the data or collecting it. That's why it might be coming. So we need to take care of that. Moving on, the next step is identifying and treating the outliers. So what are outliers? Outliers are those set of observations in the data set. It can be one or more observations which are very, very different in characteristics from the rest of the data. Taking a simple example, if we consider the income or wealth of all the people in the world, the top 10 richest people in the Forbes list would be outliers because they would have billions of dollars or billions of whatever currency uh, they would have uh, as their net wealth, right? Whereas a normal person might not even have millions in general, right? So they are outliers compared to the rest of the population because they are different in characteristic. So we can identify that in our data in various ways. One of the very, very useful and common ways is visually looking at the data. So let's say you have plot the data on a graph and you see these points. So there might be, let's say, hundreds of points or thousands of points in the data, but you see the 3 points are very different in characteristic or in trend than the rest of the data set, right? So this might be treated as outliers for this data because due to these 3 points, your entire view of the data is confusing, right? You're confused about the trend of the data if you take into account these 3 points, even though they are maybe less than 0.1% of the data set, right? But they are affecting the trend so much. So we should probably remove these values. Otherwise, all our exploration and maybe our projections will actually fail or might be influenced by these points unnecessarily, which we don't want. Then we come to a very important step called scaling of the data. It is also called normalization. So what does it mean? If you consider age, the general range of age for an adult population would be starting from 18 years to maybe somewhere around 100 or 120 years, right? Most of the population falls within this age range. Whereas height would actually be somewhere around zero point 0.5 meters maybe to maybe 2 to 3 meters at the max, right? So you can see that different variables have different scales or different ranges. So this will not be problematic right now, but down the line, when we want to have more complex operations with the data, it might create a hindrance. So it makes sense to basically normalize or scale the data so that all the variables fall within a similar range. Okay. Another important side effect of this operation is it also speeds up a lot of processes at the back end, and it helps you analyze data in a better manner, and it reduces the chance that one particular variable will dominate over the others because of the sheer range of it as compared to others, right? So no variable should get that undue advantage. You must be wondering, why do we do all this? Why are we going through all this hassle of processing and cleaning the data? So the first reason is data becomes easier to analyze. It becomes more amenable or more prone to better analysis. So that is why to make sure that we have a cleaner data and make it easier to analyze, we perform these steps. Another very important step is if you want to perform some kind of data modeling, that model will give you better results, right? If you don't understand what is meant by data modeling, don't worry. I have a video and I will give the link to it in the description so you can go ahead and check it out. But if you perform some kind of a data modeling on the data, then that makes the data ready for data modeling and it gives better results and faster results generally if you use these steps. Before I end this video, I should remind you that these steps have been outlined at a high level here. In the future videos, I will dig deeper into each of the component steps and explain the mathematics and the mathematical operations behind them in greater detail. So watch out for the next few videos.
I hope you have a much better understanding of the concepts of data cleaning and data processing after watching this video and understand what kind of steps are involved in implementing them. If you like my video, please press the like button below and subscribe to my channel to get more such videos in the future. I look forward to your comments and feedback. Thank you so much.